Once again, here's Dr. Chikit Lui to present our keynote speaker.
So, good morning to all of you. I guess you should get seated. So I could not help but commenting on the seating layout of this venue. You know, you could listen to the talks and you could have a nice social interaction at your tables. So, you know, the design of the space facilitates learning. So it gives me great pleasure to introduce the first keynote speaker of ICCE. The talk title will be on AI and education. I find it very opportune because we heard so much of AI these days. You know, lots of funding and resources going to AI. So I think it's very opportune that we hear a keynote speak on AI and education. So our speaker, Professor Benedict Duboulay, he's an emeritus professor of AI in the School of Engineering and Informatics at the University of Sussex and visiting professor at the University College London. Ben worked on two main research areas. First, the psychology of programming in the area of novices learning programming and the development of tools to assist the process. Second, the application of AI in education. He's interested in issues around modeling and developing students' meta connection and motivation. Ben has organized various workshops on the above areas. So they include the first and second international workshop on meta affect data and learning, and the workshop on interesting topic, should AI stay married to education, in Madrid in 2015. Professor Ben Duboulay has supervised 25 PhD students in these areas. He was president and currently treasurer and secretary of the International Society for AI in Education and associate editor for the International Journal of AI in Education. He has written or edited 9 books and published some 190 papers in these areas. On a more personal note, I've known Ben for more than 30 years. So 30 years ago, 1988, I was doing my PhD defense at the University of Edinburgh. And across the table was the external examiner, was none other than Ben Duboulay. So I don't know, 30 years is a long time in academia or it's a very short time. On this note, let's welcome Professor Ben Duboulay.
Thank you, Professor Lui. I'm really glad that I chose to pass your PhD so that you could say such nice things about me. No money changed hands. I'd also like to thank the organizers of this conference for inviting me. I feel very honored to be able to stand here and be the first keynote speaker. It's a great pleasure to do this. So, we can think about the futures we would like. And this is not really a future that I would like. Here, students in New York walked out of an online program of learning, not because there was anything particularly wrong with any individual component of that online learning, but because the whole day was spent sitting at laptops, occasionally seeing a human teacher. And they got bored. They didn't want to spend every day of the week sitting at their laptops learning stuff. And I think that's a lesson. I don't think that is the future. It should not be the future, because education is about human contact as well as, indeed, much more than contact with computers. So, what am I going to talk about? Well, I know my title is about the next 10 years, but to get to the next 10 years, I think we have to kind of see where we've come from. So I'm going to make a few remarks about the very early days of AI and Ed. Then I'm going to look at the middle years, and I'm going to make a distinction between screen level and deployment level pedagogy. Pedagogy is the art and science of teaching. And then I'm going to draw a few conclusions. When looking at how things have changed in terms of learning over these many years, the main trend, I think, is that the learning has become more active and more reflective. In the very early days of AI in education, some of the systems, they were technically clever, but pedagogically not so strong, in the sense that the system was completely in charge of the learner rather than the learner being in charge of the system. So, early days of AI Ed. It's difficult to know where to point the finger at the initial start of AI in Ed, but this isn't the first collection of papers, but it's a very good collection of papers from 1979, even before you did your PhD, Chikit. Okay. From a journal that was then called International Journal of Man-Machine Studies. Luckily, we've moved on from that. It's now called the International Journal of Human-Computer Studies. And if we look at the papers that were in that journal, there were 6 papers. I've ringed 3 of them that were concerned specifically with pedagogy. So we've got the paper by Burton and Brown on a coach for a game called West. We've got Clancy talking about the transition of an early expert system, MySyn, from being an expert system to being a system that can teach somebody how to be an expert. And we've got Tim O'Shea's groundbreaking program, A Self-Improving Tutor. If we just take the first 2, I want to come back to Tim O'Shea's paper right at the very end of my talk. Take the first 2. The program to be a coach for the game called West, it had a number of teaching principles. One was, do not tutor before the student has a chance to discover the game for herself. Quite a sound idea. Don't jump in too soon. The big issue in Clancy's paper was that people initially thought that simply having an expert system that was very capable in a particular area was all that you needed in order to transfer that knowledge from that system back to some novice who was learning how to be an expert diagnostician. And it turns out that's not the case. You need to have rules for how you help people learn rules to be an expert. So in this paper, there was the distinction between the D rules, the rules of the domain, in this case, infectious disease diagnosis, and the T rules, the rules for tutoring about that domain. So what's important about these 2 papers was that they tried to make the teaching, the pedagogy, completely explicit within the system, so that you could point to the rules and say, yes, my system has behaved like that because rule number 6 fired or rule number 4 fired. Okay, so and that was that has then become complete orthodoxy in future systems. So now let me move to this distinction I want to draw, which is going to drive the whole of this talk, which is the distinction between the pedagogy which is at the screen level and the pedagogy which is at the deployment level. So on the left side of the screen, you have a system. You're not expected to try to read the small print. I should have asked permission of Tanya, I think, to show one of her tutors. It's the tutor for SQL, a computer database language. And you can do the usual kinds of things with that system. It sets problems, and you can learn how to write little programs in SQL. On the other side of the screen, you can see a picture of a crowded classroom with kids, sometimes on their own, sometimes in pairs, working at terminals. You can see books and other materials, and somebody, we know who, the teacher, has organized or orchestrated that those kids should be working either on a system or with books or whatever it is, so that it's not just about the kids working with the system, it's also about what they did beforehand to prepare for that, what they're going to do afterwards after they finish with the system, what those kids do who are not actually in view and who've not got a computer, and what the rules of engagement are when there are pairs of people working at a computer. So there's a whole lot of business to be managed beyond simply what's happening between an individual and the screen. And that's why I make the distinction between the screen level and the deployment level. Just looking at a particular instance of a screen level pedagogy, I had the pleasure of working with my student Alison Hull, and we both visited Tanya Mitrovic's group in New Zealand. Alison took a version of the SQL tutor and added some extra components to it. One component was that it noticed what problem you were trying to solve, and if you weren't making much progress with it, it looked through the other problems that you had solved in the past and said, would you like to see a problem which is quite like the one you're just struggling with, but you solved before? And it gave a button for you to look at a previous problem, which was like that one. We thought that was a really sensible idea. Alas, the students never, or not never, but hardly ever pressed that button, which was a bit of a surprise given how much effort it took to get the button to do the thing it was supposed to do. But nevertheless, whether that pedagogy worked or not, that was screen level pedagogy. Now, on the deployment level, I think the person that is most famous for thinking about that as a separate area of pedagogy is Pierre Dillenburg, and he talked about the notion of orchestration. And his words are, at an abstract level, orchestration is a regulation process similar to adaptive individualized instruction, screen level pedagogy. Monitoring the situation, deciding what adaptations are necessary, and then performing these adaptations. In adaptive instruction, however, the loop is rather closed. It depends on the particular rules of pedagogy which are available and have been designed into that system. The teacher, however, thinking about watching the students working with systems, has got a much bigger range of possible things that he or she can do. She can ask other students to get involved. She can say, look, we're all tired, let's stop the lesson altogether. She can ask the student to turn away from their computers and have a group discussion. Lots and lots of things depending on the particular issues and incidents that have just occurred. So you've got something happening at the screen level, and you've also got something happening at the whole class level. And managing that whole class level interaction is called orchestration, and I'm calling that the deployment level pedagogy. So here's a kind of wiggly timeline over the last 10 or 15 years through AI and ed pedagogy. And what I've done is I've highlighted a few experiments and a few systems, leaving out huge numbers. Apologies to anybody who feels that their particular pet system is not mentioned in this timeline. There wasn't space. And I'm distinguishing by color the ones which are more, the blue text is more concerned, in my view, with deployment, and the black type is more concerned with screen level pedagogy. And they run through at the beginning from a system which I'll talk about where the teachers were brought in to really make sure that the system worked. That was one kind of deployment, through to the other end orchestration systems which were talked about at the AI and Ed conference in London just a few months ago. And what I'm going to do in my talk is I'm going to run through some of these examples of both deployment level and screen level pedagogies to give you a sense of that before I move on to the next 10 years. So we now move to some deployment level examples. Now, most of my slides are going to have a shot of a screen. You don't have to read it, okay? It's just to give you a sense of it, that's all, okay? Because we're not concerned at this part of the talk with what happens at the screen. We're concerned with the way the screens were used in the classes. So this is a shot of Van Laan's Andes system for teaching physics. And he and his colleagues had the interesting idea of not actually using it in class, but using it for homework. So the students would get lectures, they would have lab classes to do in class, and then they had available the chance to learn for themselves using the Andes system as part of their homework. And he divided the class between those that had the Andes system available and those that did not. And he ran this experiment for 5 cohort years and looked at the results at the end of year exams. So he didn't set up special tests just were going to be suited to Andes. These were the end of year physics exams that everybody took. And what he found was that over the 5 years, the average effect size of improvement, if for the students who use the Andes system for their homework, this kind of flipped classroom, was 0.61, which is quite a good effect size. So here's an example of an unusual use of an ITS where the teacher isn't around at all and the students had to kind of manage for themselves. Of course, you can argue that maybe there's a selection bias here, that maybe it was the students who were more keen on physics who would take the trouble to really work with Andes. But even so, even if we allow for that effect, then this is still an interesting result. Perhaps the most famous tutor that is most widely deployed in the world are the cognitive tutors, of which the algebra and the geometry tutors are perhaps the most famous, but there are others too. And they're a very clever piece of technology, but again, I'm interested in deployment issues here for this moment, not in how the technology works. And Koediger and his colleagues, one of the special things that they made very clear from the early days was that if you're going to introduce this kind of technology into the classroom, you have to make sure that the teachers are properly trained and properly facilitated to make best use of it. So that the teachers have got a good idea, what should they do with the kids to introduce them to this? What should they do with the kids after they've finished using it? What should they do with the kids who aren't using it? What should they do about kids working on their own or working in pairs or working in groups? All of that stuff around the system, they put a lot of effort into ensuring that the deployment was done properly. And the result is that the teachers did not feel that here were the clever guys from the university coming in to steal their jobs and tell them how to teach, because they did know how to teach and they wanted to keep their jobs. These were people who were saying, look, we can offer you a classroom assistant who can do some stuff, can't do everything, but they can do some stuff. You can offload some of your work to this nice machine classroom assistant. But to make that work, you have to gain the trust of the teachers, and the teachers have to feel comfortable in that situation of being able to offload, and to be able to offload in a way that works well. There was a big evaluation of the algebra cognitive tutor in the USA involving 147 schools, middle schools and high schools across 7 states. The schools were matched up in pairs so they could do some comparisons. And in half the schools, the teachers carried on teaching algebra in the way that they had always taught it. In the other half of the schools, the teachers were offered the cognitive tutor, but they weren't actually offered the advice that Koeniger would normally give the teachers. They would just say, here's the tutor, you use it as you see fit. There was a post-test after the end of the first year of this experiment and the second year of this experiment. And after the first year, there was not much difference between the schools who had carried on in the way they always had, and those schools that had received the cognitive tutor, which was a bit disappointing for the designers of the cognitive tutor. But not surprising, because they hadn't been allowed to go into those schools and explain to the teachers how to use the system. However, in the second year of the experiment, it was found that there was an effect size in favor of those schools that had the tutor. So what had happened in the time? What had happened was that the teachers themselves had figured out how best to use the tutor. They had self-deployed, if I can put it like that, without necessarily the advice of the designers of the tutor, showing that deployment is really an issue, because in the first year, no effect of the tutor. The second year, with the same tutor, just the next cohort of students, an effect of a reasonable size. And deployment is key there. So deployment makes a difference. Another kind of issue in deployment is it going to be one student or two students working at the system? So Walker took the algebra tutor and worked with pairs, had it working with pairs of students. So it was teaching algebra to a pair of students, and the pair of students were engaging in peer tutoring. So one student would be acting as a kind of teacher, and the other student would be that student's student. And the system tried to offer advice not only about algebra, but also about how best to be a peer teacher or a peer student. So there was advice at two levels, algebra and how to manage the peer interaction. And the peer interaction advice could either be adaptive or not adaptive, or there was one group where there was no peer advice at all. And they compared outcomes across those three groups. And what they found was that both the groups involving collaboration did better. They learned more efficiently. That is to say, they got to criterion of understanding algebra by working through fewer problems than the group that didn't get that advice. And there were all kinds of other little subtle effects, sort of not particularly concerned with ITSs, but the fact that the tutor in the pair often learned more than the student they were tutoring. I mean, remember the tutor was also a student, but the act of trying to teach the other student helped them understand better the algebra than the student that was being taught. So I thought that's an interesting issue. And we'll come back to this issue of learning through teaching a little while later in this talk. And then at the AI and Ed conference in London, we had a system called Lumillo, built by Holstein and his colleagues, one of the colleagues being Kerdinger. And here was a system for a teacher to help the teacher manage a whole class of kids working at an ITS. So on the left-hand side, you can see a class of kids, but you're looking through the augmented reality spectacles that the teacher is wearing. So what you see hovering above the heads of the kids, there are symbols. Big question mark. You can probably guess what that symbol means. That kid is a big question mark. It doesn't understand what's going on. The teacher also can see through her augmented spectacles issues which seem to be troubling the whole class. So she gets this double view, a view of issues that she might need to stop the class altogether and talk about. Look, you're all having trouble with this issue. Or issues with this kid would like to get some help, hand up. This kid is not doing at all well and maybe needs some help individually from the teacher. So here's a way of a system to help the teacher do the kind of thing that would have been nice in that big evaluation that didn't work in the first year because the teachers didn't have such a system. You can see the picture of the teacher here, and she's wearing the augmented reality spectacles. There's a couple of I'm surprised that they put this picture into their paper. There's a very surprised-looking student there, and I'm not quite sure why she's so surprised. And this one here's with her mouth open. It's kind of interesting about the dynamics of what was going on there. And if we look at some of the symbols that hover above the heads of the kids, that big question mark, unproductive persistence. The kid is trying and trying and trying, but getting nowhere. Sort of making an error, but not too dramatic. A high error after hints. Hint abuse or gaming the system. I.e. the kid is trying to get the answer simply by pressing the help button all the time. This rapid attempts, just rapidly, not really paying much attention, and ZZZ, self-explanatory, kid has gone to sleep, or at least is not doing anything. So that's a run through on issues of deployment. So where might deployment go next? Well, Lumilo is not the only orchestration system out there. There's another system called FACT, which doesn't involve the teacher wearing augmented reality specs. It involves the teacher carrying around a tablet. And on the tablet is information about the other students, and the students are working at their systems, and the orchestration system is providing for the teacher on her tablet or his tablet a detailed profile of each student and where they've got to. Not unlike the Lumilo, but without that extra contemporary technology. So it seems to me that we're going to see more of these sorts of systems. And I think one of the issues is that at the moment, the orchestration systems that we have, it's the designers who've chosen what are the issues to alert the teacher to. And it seems to me that if we're going to respect the professionalism of teachers, we need to add the possibility that the teachers can specify the issues they would like to be alerted to, rather than only being alerted to the issues which the designers of the system have decided are the ones to alert them to. So I think there's another interface that needs designing, which is the teacher interface, where the teacher can say, I want to know something that you haven't thought about a kid. Say if there's been a big change in behavior from either very good to very bad or from very bad to very good, irrespective of what the bad and the good were, just the change itself is an interesting phenomenon, and that may need my intervention as a teacher. That would be an example. The other way which I think orchestration systems are going to move is, at the moment, they report on the groupings that the teacher has made in class. So FACT, for example, knows that Mary and Joe and Peter are all working together as a group because the teacher has put them in a group. But I can see a possibility that an orchestration system could maybe suggest that the grouping is not optimal, that maybe because it's keeping a real close eye on the progress of Mary and Peter and Joe, maybe Peter really ought to go and work with Brian, because it knows that they're friends, that Brian is having some trouble. It knows that Brian doesn't really listen to the teacher, but maybe Peter can peer tutor Brian in a better way than the system can. So the orchestration system might be able to make some change to the group to produce better learning outcomes dynamically. It might also be able to interject into the group by making comments to the students. So in addition to the system making comments, maybe the orchestration system could make comments. With another student, Aurora Vizcaino, we built a system for collaborative working where the students communicated through a chat interface. And what we added in was a machine student who was pretending to be a human student. And that machine student would make comments to the group saying, hey guys, hey, let's stop talking about football, let's kind of get on with the work here. Or if they were progressing really quickly through a problem, it would say, hey, why don't we try this other way of doing it? knowing that that was a wrong way. In order to get the students to really think about whether what they were doing was correct, eventually they would say, yeah, we've now talked about this, you've given us a bad suggestion. But that little detour to explore a wrong way of solving it, quite a useful technique. So I can see orchestration systems sort of taking part in the interaction as well, at a higher level perhaps than the ITS is doing, as well as simply managing the classroom and helping the teacher. So I think there's quite a lot of possible progress there. We've also got another class of systems which are becoming quite common for dealing with cohorts. You know, so that the person in charge of a whole year needs to know whether any particular student is in danger of failing because they're not taking proper part, and can give early warning that, look, this student hasn't been seen in class for 3 weeks, has not done any of the homeworks, and they can then go and make sure, is there a real issue, and can do something about that. And I can see some ways of interacting between the orchestration systems which are working at the class level and the cohort systems which are working at the overall cohort level for some intercommunication. So the orchestration system can tell the cohort system, yeah, Mary was there, but she didn't really do very much. Okay, I think you should know. Or Peter was gaming the system all the time. I think you should know. Or the orchestration system could say something to the cohort system could say something to the orchestration system. Mary has been absent. She's been ill with flu for 3 weeks. Can you make sure that she, in the grouping, that she works with somebody who is good, who can help her? So there's lots of room, I think, for bringing these different sorts of systems, working at the individual level, working at the group level, working at the class level, and working at the cohort level together to intercommunicate. And I think that is one of the routes to the future. So now moving to my examples of screen level pedagogy. So again, we have the SQL tutor, and Naja, working with Tanya, was interested in the idea of students not just learning from solving problems, but learning from observing and critiquing worked examples. So i.e. having a problem statement and a solution to the problem, and working through the steps of the given solution to understand how that solution is a solution to the problem. So they don't have to solve the problem, but they have to understand how the solution works given what the problem is. And they also worked with the idea of faded worked examples where you get only a part of the solution. So not only do you have to kind of understand the solution, but it's got a gap in it. And you can say, well, okay, given what's just ahead in front of that gap, and given what came next, I think the missing bit in this solution is that bit in the middle. So that's an interesting way to be thinking. It's not full problem solving, it's partial problem solving prompted by the other parts of the solution. And they built a version of the SQL tutor which worked with an alternating sequence of problems and worked examples and faded worked examples. And they had two versions, one of which it was a fixed sequence, fixed sequence of such, and the other where it was an adaptive sequence. And they compared to see what the outcomes were. And what they found was that the adaptive sequence worked better, which was nice. That was an experiment that worked. And as I've already indicated with my own experiment using this tutor with Alison Hull, our experiment didn't work as well as their experiment. So top marks to the New Zealand team there. I mentioned in an earlier slide about the value of students acting as tutors. So here I've borrowed, I'll give it back immediately to Gautam Biswas, a slide from his famous system, Betty's Brain. And here the idea is that the student tries to build an understanding by building a network there of nodes and links, where the nodes are nodes about an ecology of a river system, and the links are links between those nodes of the sort produces oxygen or produces carbon dioxide, or various things, processes within the ecosystem. And the idea, but the narrative behind the pedagogy here is that the student is teaching Betty. You can see Betty here. Betty knows nothing. The screen is blank initially, and the student reads books, reads online materials, and gradually fills out this network from nothing, which is Betty's brain. This is Betty's brain, is what you see here. If this turns out to be not very good and it fails the test, then it's Betty that failed the test, not the student who built her brain, obviously. So it kind of, it removes this kind of little layer of embarrassment about getting things wrong, because you can say, well, okay, I'll have another go, I'll try and get Betty to do better next time. Now, there are some, that's at the screen level, but there are other interesting things going on here. There was also a teacher involved, I mean, a machine teacher, and the machine teacher would give metacognitive feedback. First time I mentioned that today. That is feedback about the learning behavior of the student that's building Betty's brain. Saying things like, you really haven't looked at the online materials, have you? If you look at that, you'll see that the bit that you haven't been able to fill out of her brain is all explained in that material. So it tracks what they're doing to help them understand the stuff that they're trying to teach Betty. There's also an issue about learner agency here. In the other tutors that I've already mentioned, the agency is to quite a large extent with the system. It provides the sequence of problems, and the student is expected to learn them. The sequence is adaptive, i.e. the tutor tries to choose problems which are the best one for that student at that particular instance. But here, the student can choose where to start in building this network. So not total agency, they can't decide to do something else altogether, but they do have some agency within doing this. And one of the interesting things that Gautam found over the years with this system was that the early assumption that the students were able to reason along this network in the same way that the system could reason along this network, because both of them were doing that. The system would reason along the network the student had built and said, if I believe what you say here, then this ecosystem would be dead because there'd be no oxygen. So, and the students, they found, weren't always able to reason. So one of the things they had to do in a later version of the system was actually do more to, first of all, to make sure they could understand how to reason. That was thought to be a kind of obvious how you reason, but they found that it wasn't obvious. And also, the thing that I found interesting that they did in the later versions was they took more trouble to say, this kind of reasoning has these values in other areas of your life, trying to fit why you're doing this at all into the bigger picture, which I think is a really, really important issue for any teacher. Otherwise, you have the students sort of learning the stuff and thinking, well, why do I need this? So we've mentioned metacognition. That's become a really big issue in AI and Ed, and a name much associated with issues of metacognition and helping students learn how to understand how much they understand, and also to adopt strategies to better understand, is Roger Azevedo. And he built something called the MetaTutor for metacognition. And it was a tutor, again, you don't need to read it. I can't even read it on my screen. You don't need to read any of that. What we've got here is the heart, the blood system. In the center is the heart, and we've got the veins and arteries. And it's about how the blood circulates round. And there are some pedagogical agents here who are designed to help the students think about how well they're learning this stuff. At the screen level, the stuff is here, and there are questions asked and the rest of it. but there's also a lot of attention paid to the metacognitive level. So the kind of the pedagogy that Azevedo and his colleagues are interested in, that are systems that model and prompt and support self-regulatory learning processes. And in this one, they do use it via pedagogical agents. One version of that system was designed to help students with their note-taking. What they had observed was that many students take notes, but some students take notes in a very unproductive way. They kind of copy everything down. And it's all kind of verbatim, and it isn't really very helpful because they're not really looking for the bigger picture. They're not, as it were, saying, okay, I've understood what's being said, but that now relates to this which we saw yesterday, or what was said now relates to what we heard a little bit ago. And what they were trying to do was to get the students to take more high-quality notes, but less of them, rather than large amounts of low-quality notes. And the pedagogical agents were there designed to help with that process. And they had partial success in a system where they compared students working with the pedagogical agents against another version of the system where the pedagogical agents kept quiet and said nothing. What they did find for the system that had the agents was that it did decrease the value, the quantity of notes of the students who weren't very good, but it didn't increase the quality, alas. So they got halfway there, and it's kind of interesting whether that halfway there is valuable on its own. It's kind of an interesting issue, I think, pedagogically, about whether if you stop somebody taking reams and reams of notes and just take a few notes, is that better than letting them take reams of notes if they aren't going to write good notes? Kind of, that would be an interesting experiment in its own right. So we've mentioned learning, its stuff. We've mentioned metacognition. A favourite issue of mine is issues around motivation and affect. And an early experiment by Yvonne Arroyo and her colleagues was to look for ways of improving a system called a Wayang outpost. And she built a system where the system could check for a number of different student states. So down the left-hand column, we've got mastery without effort as a possible student state. They just get there. It's easy stuff. Mastery with effort. They get there, but it's hard work for them. They hint abuse, low effort, and then there are lots more. I've only had room for 3 on the slide. And for each of those 3, and for the others too, they had a cognitive decision, a cognitive pedagogic decision that the system could make. Increase the problem difficulty, maintain the problem difficulty, reduce the problem difficulty. But the system also was concerned with the affective state of the student, how they're feeling, and also with their metacognition as well. So that there were also decisions associated with that. So under that heading on the right-hand column, show the learning progress. For the student who masters without effort, show them how well they've done. Show what they did before to what they've done now. For the student who has put a lot of effort in and got there, the effective feedback should be to praise the effort. We can see that you really sweated. That's the important thing. Not so much that you got there, but that you really put the effort in. They take their pedagogy from Dweck's work in terms of making sure the students understand that putting effort in is the route to learning, rather than hoping that somehow they'll get inspiration from nowhere, or that they can't possibly learn because they don't have the right kind of brain. They have the I can't do maths brain, or I can't sing brain, or whatever it is that the brain they have. Effort is the key rather than God's gift for the brain you've got. And in the case of the student who's hinting abuse, de-emphasize the importance of immediate success. Let's keep trying there. It's going to be good. Now, in the last few years, there have been a lot of evaluations of AI and ed systems. And I've listed here 5 different meta-analyses of AI and ed systems. And here they've compared AI and ed systems of various kinds against classroom teaching. And the numbers here, like 66, are the number of individual studies that they mention in that meta-analysis. And here are the effect sizes of those different meta-analyses. I then added them all up together, weighting the effect sizes by the number of studies to give an overall view. 182 studies, an overall of positive effect size of 0.47 for all of these different studies in favour of the AI and ed system. So AI systems have come out pretty well, just under half an effect size. Not as good as indeed, interestingly, not quite as good as Van Lane's Andy system, which was 0.61 effect size, but not bad at all. They also, some systems or some meta-analyses also compared AI and ed systems with one-to-one expert human tutoring. Okay, so this is man against machine, or woman against machine, one-on-one. And again, I've got the bars going downwards because basically the humans win. We're now talking about one human, one student. And the effect, I'm sorry the scale on the diagrams are different between the two diagrams, but the effect sizes are going downwards and they're smaller than the other side. So humans win on this one, that basically on a one-to-one situation, humans do better by an effect size of about 0.2, as compared to the previous slide where we're looking at a whole class. I find that kind of quite encouraging, actually. I'm very much for humans and still believe that humans can usually do better. I mean, there are some things that machines can do much better, but teaching is such an individual, it's an art as much as a science, and so I'm quite pleased with that. So some ways forward now that the screen level pedagogy might go. Well, I'm quite interested in the issue of why would a student put the effort in to learn at all? At the moment, what happens when a teacher gets an AI and ed system, either gets it or gets given it, is that it's down to the teacher to tell the kids, the reason why you're doing this is because, okay? It's going to help you this, it's going to help you that, so please pay attention, do your best. The system itself typically doesn't do that piece of that initial business of persuading the kids or the undergraduates, whoever it is, that actually some effort is worthwhile here. And that notion of willing to do the work is volition. So I think that there's some possibilities for systems to do a little bit more. I don't want them to do it all, because as I've already put my cards on the table, I'm very much for human teachers. But I think that systems could do a little more than they do just now. And the other area where I think they can work is that they could offer radically different ways through a system than there are available. Rather than just having one route with some little bit of adaptation in that route, maybe very different routes for different kinds of students. And people, typically that isn't offered. And I will also want to say about the developing of pedagogy through analytics, which is absolutely a hot topic. So my example of volition is to borrow from a system called Coach Mike, which was not designed to be used in a class. It was designed to be used in a museum. And the idea was that Coach Mike, a charming man there in a white jacket, would be standing beside an exhibit where you could learn to program in a logo-like language. And his job was like the guy who stands outside the restaurant sort of waving the menu and saying, "Come in, please, it's a really nice restaurant, very cheap food. For you, sir, we make a special price," all of that sort of stuff. His job was to be a salesman for, this is Chad Lane's own word, that's why I put it in quotes, and I thought it was an interesting word to use. A salesman for why you should learn this stuff, and how much fun it's going to be, and how useful it's going to be. And my thought is that if we can do this in a museum, we could perhaps do something like this in an ITS for use in a class too, where there's some time spent getting the kids in the mood for getting on with whatever it is, because they see the point of it. My classic story when I was a school teacher is I was teaching mathematics, and a very earnest 13-year-old boy came up to me at the end of a class and he said, "My dad is a pig killer, and my uncle is a pig killer. When I grow up, I'm going to be a pig killer too. Why do I have to learn about Pythagoras?" And I found that quite a difficult question to answer truthfully. I had a ready answer of the sort that a teacher should have, but somehow the question was asked, I don't think he was pulling my leg. The question was asked, a sincere question, and I found myself not having sufficiently a sincere answer to that question. So, but I've always remembered that incident, and I've told lots of people that story because it was a turning point in my downward career as a teacher before I escaped to the safety of the university. So, if we can have Coach Mike at the beginning being a salesman, we also need to think about what happens at the end of a class or a session too. I don't think we pay enough attention at the very end to gathering the threads together, to reminding the students about what they've done, to remind them about the value of what they've done to the bigger, wider world. So a kind of Coach Mike, it's still like the salesman who, when he's persuaded you to buy whatever it is, that lovely camera, tells you how great it's going to be, and you've already bought it. He doesn't need to do this, but he needs to send you away feeling good about yourself, that you've made good decisions. So I see systems doing something like that, and it might be Coach Mike waving goodbye, having had a little conversation about the content of what has happened in the lesson. I spoke about the idea of radically rearranging the way something is taught depending on how the type of student you've got. Now, I haven't seen much of this recently, but there was a system built ages ago, 1993, where students would go to this advisor called Solar. They would answer a questionnaire. They would say how much time they'd got. They would do another questionnaire to see whether they were the kind of student that preferred to learn things top down, big ideas first, then the details, or the kind of student who would like to learn things bottom up. Specifics first, then big ideas second. And then what it could do is it could design a route through the curriculum, which is indicated here. It's a statistics curriculum that would suit either a bottom-up student or a top-down student, and they would get radically different tuition depending on the kind of student they were. And that seemed to me like a really nice idea that is ripe for reviving through more contemporary ITSs. So let me kind of start to move towards the finish now, to say something about improving pedagogy through analytics. And we see analytics working at a number of different levels of granularity. In a way, the easiest use of analytics is to use them to fix a bug in your pedagogy. You see something not working really well, and you want to try and find out what's gone wrong. So use analytics to do that. And then, having delved into how people were actually behaving, you can then change the system. Chike, are you keeping time? Am I right up to time? 10 minutes. Okay, thank you. That's helpful. The next level is where you're trying to make choices about big issues to do with how you introduce stuff, whether you should, let's say on gender, you're going to have two versions of the system, one which works better for boys, another which works better for girls. That would be macro adaptive, and you use analytics with a whole mixed boys and girls, try things out and see which systems work. Then you have the way that a lot of people are now working, where you use machine learning to induce pedagogic tactics. Okay, and then we can then come back to the idea of actually having a system that sits there quietly, figuring out for itself by what to do, experiments on, running the experiments, and then changing the pedagogy all automatically. So let's take the first one first then. So a good example of analytics being used to track down an issue that students seem to get wrong in ways that the designers of the system found really surprising was Kerdigan's, this is the geometry tutor. And there was one particular place where students would make an error and they couldn't figure out what was going wrong. And only when they did the analysis of the routes through the various errors that students had made, they noticed that they had made an assumption about a particular skill which they had left as a single skill, and that needed to be decomposed into some sub-skills. And once it was decomposed and those sub-skills could be taught separately, that problem then disappeared. So they started from, we've got an issue, we use analytics to try to sort out the issue. That's the top level. The next one is, again, Yvonne Arroyo, looking at two different learner variables, gender, boys versus girls, and also cognitive development, how far developed they are. And she had two different hint characteristics that she was interested in, how interactive should the hints be, and how symbolic should they be. So is there any kind of crossover effect between the interactivity and the symbolic content of the hint, and either gender or cognitive development? So what she did was she taught a reasonable sized cohort of mixed boys and girls, of mixed different cognitive development, and randomly gave them different degrees of interactivity and different degrees of symbolic hints, and then did the analysis afterwards to see how that worked out, and was able to conclude things like boys benefit better from non-interactive and low-intrusive hints, while girls benefit better from highly interactive hints. So here were some now clues for the next version of the system to change its pedagogy such that when you signed in through the pretest and you said what your gender was, and you also indicated through the pretest whether you were highly cognitively developed or not so highly cognitively developed, the system would adapt things such that you then got, if you were a boy, you would get this, and if you were a girl, you would get the other. Okay, and a similar hint for cognitive development. So here they weren't trying to fix a bug. They had an idea that those two issues might be important, and they wanted to ensure that they deployed them in a sensible way. So it was advice towards pedagogy. So the first one was fix a bug in pedagogy. This was advice towards pedagogy. And then the third example is Chi and colleagues, where they were inducing pedagogic tactics. And they had a genuine issue about whether, this is a tutor for physics, whether the student is told what principle to apply in solving a physics problem, or whether the system should elicit with a prompt, and whether a student should, once she has made the attempt, is asked to justify his answer. So there's a question about the agency here. Should the system say, look, when we do these kinds of problems, use this principle? Or should it ask the student, what principle should we use? And then, if you ask the student, ask them, why do you say that? Okay, there's a kind of a genuine difference in pedagogy there. So what they did is something similar to Arroyo. They had a huge cohort of students, random runs through different ways of being either hinted or not hinted, and then use machine learning to find out which ones worked for the best, and then came out with a pedagogy that they could then apply in future versions of the system. And they found then that actually that worked. What the machine learning had showed actually worked better than what they had before. And my last example, I've noticed the where am I to? Am I on the 2 minutes now? Right. Okay. Quickly to the end then. So O'Shea, back in 1987, built a self-improving tutor. So here was a tutor that had a pedagogy. It had some rules about issues within that pedagogy. It would teach quadratic equations. Then it would have a think to itself, I wonder if I can do better on this. It would reason about something that might make it better. It would then change the pedagogy. It would do an experiment to see whether things had got better. If they hadn't got better, it wouldn't adopt the change. If it had got better, it would adopt the change as being a change for the future, and it would change its beliefs about the nature of pedagogy, because it had used its beliefs about the nature of pedagogy to suggest the change in the first place. So here was an experiment not only to try it out, but also to change its theory. So the system had a theory. Here's the loop it went round. The system had a theory which I called a meta-pedagogy. O'Shea called it a theory of instruction, which is beliefs about how things would change if you changed the pedagogy. So I'm getting on to my penultimate slide now. I've talked lots about AI in Ed. I'm really interested in AI in Ed. I think we should develop it, but we don't want this situation. We don't want students sitting there 24 hours a day just sitting at laptops. That would be awful. So, conclusions. I've tried to draw the distinction between screen level and deployment level pedagogy for the reason that I think deployment level pedagogy is undervalued. It's very important. Just having a brilliant system is not enough to make sure you get brilliant results. You have to think about how that system is going to be used for real in the class. I've tried to make the case that AI is an effective teaching assistant. It is not an effective teacher to get rid of teachers. It's a great thing that a teacher can offload some work. So it's an assistant. Teachers are central. They understand the kids in some ways they understand them as people better than systems do. They're maybe not so good at figuring out every single error, but they do understand them as people. And they need support. It's hard being a teacher. You're trying to manage 30 or more kids. Keeping track of all that is hard, so you need support. That's where the orchestration systems come in. Learners are human. They're not disembodied cognitive entities that you can just do stuff at laptops and it'll all be wonderful. They're human, they have feelings, they can get discouraged, they can get encouraged. And we need to remember that they are human. Teachers are human too, of course. And in all cases, we have to foster the will to learn. Unless we can make them want to learn the stuff, nothing much is going to happen between the ears. You know, they'll learn to hate being at school. So fostering the will to learn, I think, is the message there. And that's me done. Thank you very much. Yes, I've got it, if that's okay.
So we have some time for questions, comments.
Who? I don't. Okay, Ulrich, it would have to be you. Is there a microphone for Ulrich? Come out. I can't hear you. I'll answer another question.
Yeah, that works. So, Ben, thank you very much for a really thoughtful and inspiring talk. I certainly share with you your opinion about the deployment, importance of the deployment. but so this will not be my question because this is very much shared. I would focus on the AI part of this narrative. And I mean, people have been talking about an AI winter. Now we have an AI hype again. But the point is that it's not really the same AI that we see being hyped now that was behind the systems that you have mentioned largely. I mean, we see the new AI coming up. We have seen it in London at the conference, but it comes with plays a different role. It's very much in evaluation, assessment, maybe a bit in analytics, but it's no longer inspiring design. So the new AI that is hyped has not yet brought forth new, I would say, design ideas. And what you were talking about, and this is also my interest, were the design ideas. But I don't see that. So I think the new AI will create problems in this sense.
I agree with you, Ulrich. I have seen some examples of AI, contemporary AI, bringing in design. You see people building essentially recommender systems for a student. So they start to learn both about cohorts of students using machine learning, and they learn about an individual student, and they suggest to that student that, look, we think that if you were to go and work on this next learning object followed by that learning object, that would be a good route for you because it was a good route for other students. So in a sense, that's kind of at the design level. It's not doing the kind of deep mind AI that is now being hyped so much. But I agree with you that it is largely a different kind of AI. And another example, just to back up what you said, O'Shea's system was using symbolic AI to reason about how to change the pedagogy. Chi's example was machine learning techniques, black box systems to figure out what would work and what wouldn't work. So it was to a good end, but very different AI. Yeah. Yeah.
Hello. This question is kind of extension of what he asked. So the AI that you talked about, it talked about assisted or scaffolding the presentation or management of content and information, and helping teachers in orchestrating the classroom, which you characterized as screen level or deployment level pedagogy. My question is, how do you think AI could inform or improve exploration of other affordances that digital media provide for interaction with the symbolic entities like touch or virtual reality based interactions? And this question is important from learning science or cognitive science point of view. And the study that you cited, like Arroyo et al., like this, that study slightly touches it, but touches it at the level of gender or cognitive development, but in terms of understanding deeper learning patterns, and in terms of other affordances that digital media provides. So how do you think AI could help in exploration of those spaces? Thank you.
Well, I think the most famous tutor, the cognitive tutors out of Pittsburgh, they were built based on a view of learning coming out of Anderson's theory, the ACT theory, and the design of the tutors followed directly from that theory, which is why many of those tutors were designed to give immediate feedback on if the student made an error. There was also a pragmatic reason for giving immediate feedback, which was that if you give the feedback immediately, the system is more able to get the student back on track than if it waits a while and loses any idea of what the student is doing. But the issue, to answer your question, is that we had a theory there that said this is how people learn. They move from a kind of declarative understanding to procedural understanding. And they built tutors and tried that out. And what they found was that it sort of worked, but there were plenty of times where it didn't quite work as well as it should have worked. So I think the answer to your question is that in AI in education, there's quite a long tradition of trying to involve cognitive science, learning theory, building systems that embody that theory, running educational experiments which don't always work, and then going back to the theory. So Azevedo's work, when you read his work, you'll see that his tutor is based on a large amount of theory. The volition work from Keller was based on a lot of theory. Keller and his colleague built a tutor based on theory. And again, there's been this going backwards and forwards between theory and experiment and change of theory. And that's central to AI and Ed. A lot of educational technology that I've seen, not in the AI and Ed tradition, hasn't typically been much rooted in theory. It's been rooted in what's buildable. So I think that we're in good shape in AI and Ed for helping build systems that are better than the ones that we've had, because that's what we've always tried to do. I tried to give the sense somehow of AI and Ed progressing, broadening the ways things were deployed, changing the screen level pedagogy with a view that that was going to carry on in the same way. But it was a good question. Thank you.
Thank you.
Are we done? Okay.
So, thank you, Ben. I think Ben has given an excellent overview of the state of development of AI education in the past 10 years and project what are promising directions and areas to look at in the next 10 years. So I think as a community, we have hope you're excited, and I think there are very promising areas for us to get into these directions. So thank you, Professor Duboulet, and on behalf of the conference organizers, I'd like to present Ben with a token of appreciation. Yeah.
We can now get our food for snacks, and the next session will resume at 11:30.